All right, so today we are going to be graphing linear functions. There are 3 different forms that these will take, and I have 2 examples for each. Okay, so first one that you are probably the most familiar with, is called slope-intercept form. And the reason it's called slope-intercept form, which by the way is y equals mx plus b, the b is your y-intercept, right? And the m is your slope. And we normally write the slope as a fraction if we can, because again, slope is normally thought of as rise over run. So we kind of need to know how far it's going up and how far it's going over. So, and then again, the y-intercept is also given in this equation, and that is a specific point on the y-axis. Okay, so in slope-intercept form, we start our graph at the y-intercept point, which in this case is -5. So that is the point 0, -5, because it's on the y-axis, and that means the x value of the point is 0. So 0, -5 starts right here. Okay, so we start at the y-intercept, 0, -5, and then your slope, again, is that m value in front of the x. So it is 2 over 1. So our rise is 2, and our run is 1. And we always run right, okay? Because negative slopes go down and to the right, positive slopes go up and to the right. So from our y-intercept, we are going to go 2 squares rise, that's up, and 1 square run. So rise over run. Do it a couple of times, that way you can draw a really nice straight line. Okay, and once you are done with the points, connect the dots, make sure the line rather goes all the way across your graph. It's not just some tiny little line. It does keep going forever and ever. That's why we put the arrows on the ends. So again, once you've got your points based on your y-intercept and your slope, connect the dots, go all the way across the graph, and then make sure you put the arrows. All right, so let's try another one in this form. Again, slope-intercept form. Okay, our y-intercept, again, remember that is b. So my y-intercept is the point 0, 4, 4 places up on the y-axis. And our slope, again, is m, whatever's in front of the x. So that is -5 over 3. So I'm going to rise negative. That means we're going down. And I'm going to run 3 to the right. Okay, so y-intercept, 0, 4. It's my starting point. And then from there, I'm going to go down 5 squares. That's how you do the negative. And then go to the right 3. 1, 2, 3, 4, 5. 1, 2, 3. If you need to count the squares, go ahead just to make sure you're there. I do at least one more point so I can make my line nice and straight. 1, 2, 3, 4, 5. 1, 2, 3. And you think of them like stair steps. Again, down 5, right 3, down 5, right 3. And if we wanted to, we could continue the pattern and it would go off the graph, but that's okay. Because again, these lines go forever and ever, right? They don't stop just because we run out of room on the graph. That's why we put the arrows on, to show that they do keep going. Okay, so that's slope-intercept form. So let's try the next one. The next form is called standard form. And standard form looks like this. AX plus BY equals C. Okay, this is actually pretty easy. We're not going to be pulling the slope. You can, but we're not going to be pulling slope. And you don't have to rewrite this like you did with the literal equations. You don't have to rewrite this to get the y by itself. It's not needed. Now, again, you can get the slope. There's a very easy way to get it. But we're going to use what we call the intercepts. The y-intercept, just like on the last type of function, is where it's on the y-axis, right? So the x-intercept must be where the line crosses the x-axis. And it's very easy to get these. Okay, so the y-intercept is when x is 0. That's why it's the point 0 something. Okay, so the x-intercept is where the y equals 0. So it's written like a number and then 0 for the y. So those are your 2 points, your x and y values to graph your points. So it's very easy. If I want to find the y-intercept, I have to make my x equal 0. So I'm going to substitute 0 in for x. Slide down a little bit. So if we substitute 0 in for x, we get 2 times 0 plus 3y equals 6. Well, anything times 0 is just 0. So really what we have is 3y equals 6. And I need to solve for y. So in this case, I have to divide by 3. If I divide by 3 on both sides, I should get y equals 2. So that point, when x is 0, y is 2. Okay, think of it like function notation when you're plugging in something for one number and getting it out for the, input and for the output. Okay, so now let's do the same thing for the x-intercept. I'm going to make y equal 0. So I have 2x plus 3 times 0 equals 6. Again, anything times 0 is 0. You don't have to include it. So what I have is 2x is equal to 6. And then I have to divide by 2 to solve. And I get x equals 3. So your x-intercept is the point 3. So x is 3 when y is 0. So that's this point here, 3, 0. Okay, now if I wanted to get the slope, I have these 2 points. I can now do rise and run between them. So I'm going down 2 and to the right 3. So my slope, if I actually want it, is -2 over 3. So I can get another point so I can make sure that my line is nice and straight. So I can go down 2 and over 3, rise 3. Or sorry, rise -2 and run 3. So I have my line, connect the dots. Make sure you put your arrows at the end. Again, this is very, very easy, again, because we are just making either x or y 0. So if you do that, all you have left to do is to divide to solve it. So let's try another one. Okay, so standard form again, ax plus by equals c. Okay, so the only thing that you have to remember is that the y-intercept is when x is 0. So if I substitute in 0 for x, if I make x 0, 0 minus 4y equals 10. Okay, the 0 goes away, so I'm basically dividing 10 by whatever number's in front of my y. So what is 10 divided by -4? Should be -2.5. Okay, do the same thing. What is your x-intercept? Well, it's when y is 0. So x minus 4 times 0 equals 10. So in this case, I don't even have to divide because the 0 cancels. It's just x equals 10. So it's the point 10, comma 0. So let's graph our points. So 0, -2.5 is here. And 10, 0 is here. Now, I'm not going to be able to do another point just because I've run out of room on my graph. But if I wanted to, I could go up 2.5 more and 10 more to the right. So let's connect our dots. Hopefully it'll be nice and straight. And arrows on the end, and we're all done. But again, like I said, if we wanted to get the slope, you're rising 2.5, 2.5, and you're running 10. Okay, so let's try point slope form. All right, so this one. All right, that is what point slope form looks like. Now, here's how this works. You're actually given a point in your equation, okay? A random point that's somewhere on the graph. The x and the y, the plane x and the plane y, that's just what's in every single equation. See, take a look. That's got an X and a Y in it. That's got an X and a Y in it. Those are in every equation. You've got to have an X and a Y when you're, or not equation, function. Got to have an X and a Y when you are graphing, because that's how we find our coordinates, our ordered pairs. The other X and Y, the X1 and the Y1, is actually the point that's somewhere on your line. There's one catch, okay? Notice that there is a minus in front of both of those, or a negative, okay? You have to change the signs. So if X1 is here and it's +1, it actually becomes -1. And the Y1 over here right now is a -2, so that becomes a +2. And that's just a random point that is somewhere on your line. So -1, +2. So there's your point that you're going to start at. And again, always change your signs. Okay, the next part is easier. It's just like what we did the first time. Your slope is right here. It's right in front of the parentheses. And in this case, my slope is 1/2. So that's a rise of 1 and a run of 2. So instead of starting from the Y-intercept, this is the only way this is different. Instead of starting from the Y-intercept somewhere on the Y-axis, you're starting from that random point and using your slope. So my slope is rise 1, run 2, rise 1, run 2, rise 1, run 2. And I could keep going if I wanted to. There's enough room. And then we're going to connect the dots and put our arrows. So again, this is very similar to slope-intercept form, but instead of being given a Y-intercept, you're given a point. So big thing on that is just remembering to change your signs. Let's try another one. Okay, so take a look. Your point, and I'll write the form again just to make sure you have it. Okay, so your point should be +1, change the sign, and -3. So 1 to the right and 3 down, because your X, you're going 1 positive, and your Y, you're going 3 negative. So there's your point. And then your slope is -2. Now, I'm going to put that as a fraction because, again, I want my rise over run. Now, if you should remember that to make any whole number a fraction, you put it over a 1. So I'm now going to rise -2. That means I'm going down. And I'm going to run 1 to the right. So starting from my point that's in my equation, I'm going to go down 2 and to the right 1. 2, right 1, down 2, right 1. And then I'm going to connect my dots. And I'm all done. And that is it. That is the 3 forms of graphing linear functions.